Hi all. Today we're going to see about the thermal management. In previous class, we saw about what are the UPS and its electrical battery and its application and its types. So in today's class, we're going to see about what is thermal management. So thermal management, why we go for thermal management and thermal management fundamentals and how it is maintained in ICs and PWB packages. Let us see in detail. So why we go for need of thermal management is something that it ensure long reliability and also it guarantee performance and functionality. So the see this below figure, you can see the what are the percentage of failures occurs based on the temperature. So let us see what is thermal management. So that thermal management is a heat generated by an electric resistance of leads and polysilicon and transistors, and the absence of cooling will result in constant rate increase in temperature until the component ceases to operate. So placing the device into contact with a component at lower temperature and facilitate the removal of heat flow away from the component. So presence of a cooling and the temperature rises in order to approach an adaptable steady state value. So at the steady state value, all the heat is generated and the components is transferred to the surrounding structure and or a fluid. So see in this process, let us see about the what are the cooling process. Whenever heat generated, there will be cooling, which means heat removal, so that it maintains a steady state and the heat transfer occurs by thermal conduction, convection, radiation, and phase change. So this is a successful thermal packaging process, and so that the stable temperature has been maintained. Okay. So whenever there is no cooling process, what happens? The components fail and it ceases to operate. So thermal management is important to maintain the temperature. So these are the challenges of thermal management. So what is high? It will provides high temperature. Whenever the high temperature reaches, we need to maintain it. Next is material degradation and system complexity, failure rate, and also temperature compensation and fail-free operation is required. So this is a graph represents the effect of temperature on failure rate. So let us see the failure rate increases with the temperature due to mechanical creep and also bonded materials and prolonged exposure. Continuous usage of material uses a high temperature and elevated temperature. When there is a fluctuation in temperature, it happens and unwanted reactions and due to the chemical reactions also, and dopant diffusion and spreading the dopants in high temperature, and whereas poor interface materials and these are the main causes for electronic components failure at high temperature. So packaging levels and heat removals. So this table represents the passive cooling techniques and active cooling techniques, and these are the types how to maintain the temperature is maintained. These are the packing levels. Hope you open the system or a CPU, you used to see like this. So these things, there will be a coolant, so that if the system has been overrun, the fan will be automatically on and it will reduce the heat capability, or it will reduce the temperature, so that the thermal management is done. So let us see the characteristics of heat dissipation technology comparison. So whenever the heat sink assisted helps in maintaining the environment, whereas fan cooled heat sinks does not maintain the environment. Power dissipation is around 10 to 15 volt, and for fan cooled it is not mentioned, and the operating temperature is 175 degrees Celsius. The heat sink is assisted, and technology where uses clip attached. Here the fan cooled heat sinks. The application is wherever we use heat sink is in notebook or desktop, wherever the fan cool system is mainly used in notebooks, and cooling system is based on your heat sink is external fan, and here also fan has been used, and there is a gap in ionization. So this is the heat dissipation comparison table. So in today's class we saw about what is thermal transport mechanisms, that is conduction, convection, and radiation. So this is the efficient heat removal. We are removing the heat in the process of thermal management. Okay, let us see the one-dimensional condition. So conduction of heat transfer, the flow of heat from one region of high temperature to the region of low temperature within a solid or a liquid or say a gaseous medium. So it occurs as a result of a direct energy exchange among the molecules, and it has been calculated. Q is represented the heat flow, and K is represent the constant of thermal conductivity, and A is cross-sectional area, and the differentiation is with respect to the temperature. So this is one-dimension conduction of various elements, and this is a conversion based on the various elements. And also thermal radiation is the radiation occurs as a result of emission and absorption of the energy contained in electromagnetic radiations. So here Q equal to emissivity and Boltzmann constant with respect to the radiation and the temperature. And this is a formula for thermal resistance. So to calculate it is based on the Ohm's law. And let us see the thermal resistance of conductions and based on the electrical resistance and also temperature. So here for resistance is a voltage in the incoming voltage minus the output voltage divided by the current, which is represented in the unit of ohm, and whereas temperature is the incoming temperature minus outgoing temperature for power dissipation. So it's a prototype. So in today's class we saw about thermal management and its type, what is conduction, convection and radiations. And if you have any clarification related to this topic, feel free to contact me. Thank you. So here the quiz is the main purpose of heat sink is to store heat or dissipate heat or convert heat to electricity or block airflow. The answer is to dissipate heat. So if you have any clarification related to this topic, feel free to communicate with me.